Hey class, it's Professor Bork. So I had a question about one of my math lab homework questions. This was from 10.2. This is number 20. So you know when they're towards the end of the assignment, you know it's probably going to be a little painful. So let's see if we can figure out how to solve this problem and figure out maybe why this one could be particularly tricky. Okay, so this problem says a certain bank performed a study in 2012 of 1,020 residents from a certain country, 18 years of age and older. Okay, it was reported that 63% of residents have a certain retirement savings plan. A study from 2001 reported that 52% of residents had the same retirement savings plan. Complete parts A and B. Okay, so before we even start going into the actual question for part A, let's just kind of identify what they do give us, okay? So it says there's a bank, it performed a study in the year 2012 of 1,020 residents. So I'm just going to go ahead and jot down that N equals 1,020. For a lot of these problems, I think it is helpful to kind of have a piece of paper to write down some of the information. So I know it seems like on a computer class, sometimes that just seems like you wouldn't really think to do that, but it is really helpful, especially at the end of this class where there's just a lot of information given and it can help to sort of keep things straight. Okay, so it says that it was reported that, among this study, the 63% of residents have a certain retirement savings plan. So I'm going to go ahead and call that would technically be P hat. So I'm going to put P and then I'm going to go back and add a little hat to it. So that's my sample proportion is 63%, which is 0.63 as a decimal, right? Okay, then it says a study from 2001 had reported that 52% of residents had the same retirement savings plan. So that is technically what we're going to assume to be true. And it's sort of confusing because the way they write this, it comes after the sample information, but because this is a study back from 2001, we always assume good, right? We assume that the study that was done before was done correctly and that is the correct value in hypothesis testing. We always assume the original hypothesis is correct, the original proportion is true, and then we test to see if it's changed however way. Okay, so I hope that makes sense that we have from those first two sentences, we have the sample size is 1,020. We also have that the sample proportion is 0.63. And we also have that the assumed to be true population proportion is 0.52. Okay, so a lot of information there, right? And then part A, let's actually get to the question. So it says, create a 95% confidence interval for the proportion of adults in the country who have invested in a retirement savings account based on the survey in 2012. Okay, so this is technically, could have been in theory, a question from chapter 9 at this point, right? Where we're asked to make a confidence interval. In chapter 10 is where it's very similar, but also a little different because we are given, unlike chapter 9, where we just have a sample proportion and we make a confidence interval. Chapter 10 introduces hypothesis testing. Oh, let me go ahead and open up StatCrunch a little bit of a different way. Okay, sorry. Sometimes when I open and ask my instructor a question, StatCrunch is a little tricky. Okay, so thinking back to chapter 9 and how we make a confidence interval, let's see if we can figure out what is so challenging about this problem, because it is tricky. Okay, let me go ahead and move my data points above so you can still see them when I have StatCrunch open. Oh, the hat. Let's move the hat. Oh, the hat got bigger. Okay, hat, P hat, little hat. Okay, so let's go ahead and go. This is a proportion, right? So don't forget, you do have those StatCrunch steps. I want you to use them. I want you to have them printed out if possible, especially at the end here. It's just so many different StatCrunch steps. And what I've started doing in my in-person class, if someone has a question for me and they haven't looked at the StatCrunch steps, I say, let's look at the StatCrunch steps first before you call me over, because I don't mind answering questions at all. But it's just, if I'm just going to say, what do your StatCrunch steps say? That's something we would want to be able to do. Okay, so this is a one, let me go through that again because I was rambling. Stats, proportion stats. This is one sample. The only thing left to do in chapter 11 is we're going to start taking a look at 2 samples. And then this isn't with data. So with data for this, we never really have with data for proportion stats. That would be like a whole list of the 1,020 people, whether they have a savings account. So it'd be like, yes, 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 no, 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 yes, it's like over. We don't hardly ever see that. Okay. So we are typically always going to click with summary. And this is where I think the problem came, because for whenever we do this in StatCrunch, we have to enter in the number of successes. However, they don't give us the number of successes, right? This is the last problem. Like number 20 is always going to be a can of worms. So we have the number of observations. We know that that is like the sample size, but we don't have the number of successes. So what do we do? Okay, and they like to sometimes do this, but we have the sample proportion. So either the question is going to give you the sample size and they're going to give you the number of like X, the number of people. Or if they don't, they have to at least give you the sample size and we can figure it out, because we really need to find what 63% is of 10,020. Okay, because like technically back in, I think chapter 9 technically, but I feel like also it sort of has come up before. We talked about how the sample, like sometimes they'll call it the point estimate, the sample proportion is X divided by N, right? Like if they gave us the number of people who had a savings account and the total number, we could just divide them. But the same works vice versa. Like technically, if I multiply both sides of this by N, N, the sample size times the sample proportion, is going to give us X. Okay, it's going to tell us the number of successes. So I hope this makes sense. And also like intuitively, I feel like it makes sense. Like I just need to find really what is 63% of 1,020, right? So to do that, I can multiply it. Okay, so I got 642.6. So I'm just actually going to use that, even though it doesn't, like for right now, make a lot of sense. Like how would we have 0.6 of a person? We could also use 643. And if this was a question that asked you to perform a hypothesis test, we could do that. We would put in, we'd leave this selected on hypothesis test. We would enter in the given population proportion from the 2001 survey, which was 0.52. But that's not what they want us to do right now. They want us to make a confidence interval. So we can do that by selecting confidence interval, and the level is 0.95. I think that's what they want. And so let's go ahead and figure out how we can fill in this answer. I'm going to try to see if I like to do a little split screen action because I know this is so many numbers. But again, if you have a piece of paper in front of you, this also might be helpful where you can go ahead and jot this down. Okay, so it says to type integers or decimals rounded to 3 decimal places as needed. Okay, so I'm going to go ahead and clear off this piece so we can see this. And I'm going to go ahead and type in 3 decimal places as needed. So the lower limit would be 0.600 and the upper limit would be 0.6. I guess that would be 5.9, but the 9 would get bumped up to like a 10, which would then bump up the 5 before it. So we'll say 660. All right, so let's give this a try. Put my Zoom bar out of the way. Okay, so what does this mean, right? So this means that if we are basing off of our sample of 63% of people had this savings plan, we are 95% confident that the true population proportion is somewhere between, and I like to think about this as percentages, 60% and 66%, okay? And then they reverse. Now they go back and say, does this provide evidence of a change from the 2001 in retirement savings vesting among adults in the country? So they introduce in chapter 9 confidence intervals. Okay, we can make a prediction about what the true proportion would be. Then chapter 10, they introduce this idea called hypothesis testing, where we are then given some kind of assumed to be true proportion that we're going to think is correct until we have evidence to say otherwise. Okay. The last section here kind of combines the two together, right? Where we actually make a hypothesis test and a confidence interval like together. So we use the confidence interval to say that we think the true proportion is between 60% and 66%. But back in the day, in 2001, it's supposed to be only 52%. So what do we think happened, right? So we're thinking it probably maybe has gone up. So to reread this, it says, does this provide evidence of a change from 2011? Using your confidence interval, test an appropriate hypothesis and state your conclusion. So the options they have here, A, B, C, D, E, and F, and they are different combinations of using like the 63% value or the 52% value. So A, C, and D, I'll use the 63% value as the hypothesis test value, and then B, E, and F use the 52%. So we always, this can be tricky. We always want to go with like the original assumed to be true value for when we're writing our hypotheses. So we're like assuming 52% is still true until we have evidence to possibly reject it. So we want the hypothesis test that has 52% in it, and it looks like it's higher, right? So what we're looking for is the null hypothesis to be 0.52 and the alternative hypothesis to be greater than 0.52. So that looks like for this problem that I'm using, which yours could be a little different. Oh, sorry, are 0.52. Sorry, pause a second. Oh, okay, this one's tricky. I think they want us just to say that it's, quote, changed. Like we can look at this and see that it's gone up, but technically this one was super tricky because it just says changed. And so we don't like in theory know if it's gone up or gone down. We just think it's different. So when that happens, they want us to use not equal to, which, you know, I feel like intuitively I'm thinking we think it's gone up, but that's okay. All right, so it says, what does the confidence interval indicate? Explain. It says, since the percentage of adults who had the retirement saving plan is or is not in the confidence interval. So the percentage of adults who had the retirement savings plan, they're referring to the 52%. Okay, 52% is not between 60% and 60%, 66%. I know these are always really annoying. All the drop down, I'm like, oh God. Since the percentage of adults who had the retirement savings plan is not in the confidence interval, we can reject the null hypothesis. So there is strong evidence that the true proportion in 2012 is this. There is, strong evidence that the true proportion in 2012 is the same as it was in 2001. Ugh, that's annoying. Okay, so there is not strong evidence that the true proportion in 2012 is the same as it was in 2001. I feel like that's worded backwards. Usually we just say either there's evidence that we can reject, or there's evidence that we cannot reject, or there's no evidence, so we cannot reject. This is like kind of just really making it more complicated than it needs to be, but that's okay. We will persevere. And then the study in 2012 indicates the percentage of adults who have a retirement savings account. And then we would technically say increased here, right? Because it's gone up. But I don't love a few things about this. One thing I don't love is that they want us to say not equal to, and then back here at the bottom, they want us to say increased. That's confusing. Okay, I feel like if this was a particular question on a test, I would either say, we're looking to see if it's increased, right? And then we would have that as increased, and it would make sense for us to then use the word increase down here. Right now, technically, we're looking for evidence that it has changed because that is what the not equal to sign means. But that's just kind of being nitpicky about the wording. I feel like it makes it more confusing than it should be. If we reject it, that means there was enough evidence to say that it's changed. If we do not reject it, then we do not have sufficient evidence. So we do reject it, but here the wording's bad too. So there's a couple of things I don't really like about this problem. I'm sorry. But the one thing I do want you to be able to do is if you're given a sample size and you're given a sample proportion, I want to make sure you guys are able to multiply those together to get out X. Okay, that is one thing you do want to be able to do. And then also be able to write the hypothesis test based off of the original assumed to be true population proportion. Okay, so I hope this was helpful. I know I did not love these last two parts here. I just kind of Personally, I think it would make more sense to say in the wording originally to look to see if it's gone up. But since it says they're just looking to see if it changed, we'll technically say not equal to, but then they shouldn't have said increased at the bottom. They should have just said changed, right? But that was not an option. It was either increased, decreased, or stayed the same. Lord above. Okay, so I hope that was helpful. But if you have any other questions, please let me know. This one, again, is particularly challenging. For the final, you don't have to worry about a question particularly like this. I vet the questions and make sure that they are hopefully as clear as possible. Okay. And so the part about the change, but then also, so not equal to, but then using the word increased, I'm not a fan. Also saying that there is not strong evidence to say that it stayed the same. We would have said it the other way, where we would say there is strong evidence to say that it has changed. So I hope that makes sense. But please keep me posted. Oh, sorry, my dog's whining. About whatever I can help answer. Chapter 9 and 10 are challenging for sure. 11 just kind of is like the same as 10. So it is really important that anything in chapter 9 or 10 that you don't understand, that please let me know. Don't forget to have those formula sheets and StatCrunch steps out in front of you. Between the normal CDF button and then the normal calculator button in StatCrunch, then combined with proportion stats, then combined with T-stats. It's a lot to kind of keep track of. So please have those printed out. If you don't have a printer, but you come to campus, let me know. I can get you a copy, no problem. And don't forget to use my office hours whenever you need them. Okay, thank you so much. Bye.